Welcome to your first lesson for our Intermediate Algebra online course. If you haven't already watched my introduction video, please allow me to introduce myself. My name is Jillian Stugard. I'm very happy to be here with you this semester, and I look forward to working with you and getting to know you and doing fun math with you all throughout the semester, and I hope that you are as excited as I am. So for our first lesson, we're going to begin with a little bit of review. This presentation will be all about polynomial addition and subtraction. So I hope you are able to sit back, take notes where you need to, just listen maybe the first time and then go back and rewatch it. The really great part about taking a class online is that you are able to pause when you need to, take notes as you need to, go back and rewatch the video as many times as you need to. Me personally, I like to just watch the first time and then go back and sort of work through some of the math myself. But you will be noticing that throughout this video, it will prompt you to stop and answer some quick questions. And the purpose of that is really just to, one, check for understanding. Two, it allows you to see where you may need to go back and rewatch because you might not have understood the first time if you're unable to answer the question. They're like little mini quizzes. And three, I get to see how you guys answered these questions when you take these little mini quizzes. So it sort of allows me to see what you guys are struggling with, what I might need to go back and review a little bit more, and how much you've learned and gained as we get into more and more lessons. So don't get nervous about them. You're not going to be graded on the questions that you answer within our video lectures. They're really for you and for me to guide your understanding and to guide my instruction so that you know where you're sort of struggling and I know where you're struggling and I know and you know what you've got down pat. Okay, so don't get nervous about those. They're ungraded. The video lecture quizzes are completely ungraded. They're really just a quick check for understanding for the both of us. So I hope you're able to sit back, enjoy doing some math, get yourself ready, and let's get going. So before we can jump into doing the math, let's make sure we have an understanding of the definitions of what we're actually dealing with. You'll always see me start a new unit with some definitions because we need that baseline of, well, what even is this stuff before we can play with it mathematically. So let's talk about what are polynomials and what are the important definitions that we need in order to understand them. So a polynomial, and this is going to sound like a bunch of gobbledygook, but we'll talk about it. It'll make more sense as we go. It's an expression of more than two algebraic terms, especially the sum of several terms that contain different powers of the same variables. So let me show you some examples. It'll be much more clear. This is a polynomial. It is a one-term polynomial, but it's a polynomial nonetheless, 4x squared. You'll notice it has a number coefficient, a variable that is being raised to a degree. Okay, that's all a polynomial is. Now, usually we'll have several of them, okay? That is a one-term polynomial. Here we have a three-term polynomial, 5z to the 8th minus 4z cubed plus 6, okay? So this polynomial has 1, 2, 3 terms, all right? That's another polynomial. Again, you'll notice that there are coefficients, variables, and those variables are being raised to a degree, all right? Here's another polynomial, okay? 23y to the 10th plus 6y to the 7th minus 15y to the 4th minus 2y. Okay, this polynomial happens to have 1, 2, 3, 4 terms. Okay, you'll notice you can have addition or subtraction in there. It doesn't matter, but this is what these are polynomials. Okay, many terms being added together, summed together, added, subtracted together. All right, that is a polynomial. A coefficient is a number used to multiply a variable. And you'll hear me refer to coefficients as just the number throughout the semester, okay? So let's look at our first example, 4x squared, our first polynomial up there. What coefficient are we dealing with? Well, it's just the number that we're multiplying our variable by, so it's 4, okay? If we look at our second polynomial, 5z to the 8th minus 4z cubed plus 6, what are the coefficients there? We have 3 of them, 5, okay? 4, and 6. So the coefficients are just the numbers. So I want you guys to just quickly pause and look at that third polynomial, and I want you to identify the coefficients now in that polynomial. So let's see if you can do it. Okay, what is the degree? The degree is the highest exponent. So when you're dealing with a polynomial, you want to look at the exponents, those little numbers in the air, okay, those powers, and you want to see which one is the highest. That is the degree of the polynomial. So again, if we look at our first example, that one's pretty easy. There's only one term, so there's only one exponent, and that's 2. So this is a degree 2 polynomial, okay? If we look at our second example, it gets a little bit more complicated, but not that much more. We have 3 terms. We have to look and see which degree, which is the highest. So let's look at those degrees. We have 8, okay, our first variable, our first term, 5z to the 8th. The z is being raised to the 8th power. In our second term, minus 4z cubed, the z is being raised to the 3rd power, okay? And it is worth mentioning that if we look at our last term here, this 6, right? There's no variable and there's no power, but I do want to mention that there actually is an invisible variable and an invisible power here. So this is like having 6z to the 0 power, okay? Anything to the 0 power is just 1. So this is like 6 times 1, okay? Z to the 0 power is just 1. 6 times 1 is equal to 6. So we could make the argument that there is indeed a power there. It's just 0. We could make that argument, all right? So whenever you have just a coefficient, just a number, you could make the argument that there is that invisible 0 power there. That's not something I want you to get hung up on. I just wanted to mention it, okay? So I'm going to erase that. So if we look at our degrees in this polynomial, what's the biggest one? 8. So this is a degree 8 polynomial, all right? So we had the degree 8, the degree 3, and that invisible degree 0. What's the biggest one? Of course, 8 is, okay? And again, I want you guys to now take a look at that third polynomial that we saw up top, and I want you guys to decide what the degree of that polynomial is up here. So what is the degree of this polynomial? Check for your understanding. So now I just like to quickly check for understanding and usability of these different vocabulary words now that we've gone over. So let's look at some terms that we could pull from polynomials and figure out the coefficient and the degree. So if we look at our first term, 5x to the 8th, the coefficient is of course just the number, so 5, and then the degree here would be 8. That's the power that your variable is being raised to. So that's where we got 5 and 8 from. All right. Let's look at our next term, negative 1/4 y to the 4th. Okay. So in this term, we actually have a fraction for our coefficient. So our coefficient, remember, is the number in front of our variable. That can be a fraction. And it can be negative. And whenever you have a negative, you need to take that with you as part of your coefficient. So because we have negative 1/4 y to the 4th, our coefficient, our number, is the entire negative 1/4. You have to take that negative with you. And of course, our degree, the power that our variable is being raised to, is 4. Okay. Let's look at our next example, 7z. Now, I put each of these examples on here for a reason, you guys, okay? I wanted you to see a negative. I wanted you to see a fraction so that you weren't upset when you saw them in when we started doing the math. This 7z is on here for a very specific reason. So if we look at this term, the coefficient, the number in front of our variable, that's pretty obvious, right? It's the 7. What's our degree? Here we have z, but we see no number that it's being raised to. We see no power. Well, when you just have the variable with no number floating up there, you guys, it's like there's this invisible 1, okay? Anything to the first power is just itself. So z to the first power is just z. 2 to the first power is just 2. 3 to the first power is just 3. Negative 4 to the first power is negative 4. It's always itself. So as mathematicians, we don't write that 1, but there is like this invisible 1 right here, okay? So the degree here is 1. That's important. We are going to use that as time goes on. And then, of course, we sort of talked about this on the last slide, but here we just have a number. Our term is just 5. So the coefficient's really easy, right? Because the coefficient is always just the number, so 5. But what's our degree? And again, when we don't have a variable, it's like we have this invisible variable being raised to the 0 power. So it's sort of like maybe if we were dealing with z's, we have z to the 0 power, because anything to the 0 power is just 1, which would make this 5 times z to the 0 power, which would just be 1, which equals 5. So there's where our number comes from. So whenever you have just a number without a variable being raised to a power, the degree is 0. It's like there's a variable being raised to the 0 power there. Okay, so I wanted you guys to sort of see examples of each of these things. All right, and now I want you guys, let's check for understanding. I want you guys to see if you can identify some coefficients and degrees when you are given some terms here. So take a second and do that. So there is one more definition that you guys need to know in this section, and that is the term like terms. So like terms are terms that have the same variable, so the same letter, okay, x, y, z, w, and the same degree, the same power, okay, whether they're being squared, cubed, okay, you want to look for terms in your polynomial that have the same variable and the same degree. And if they have the same variable and the same degree, they are known as like terms. So if we look at these two examples I have here, let's first focus on 5z to the 8th minus 4z cubed plus 6 plus 6z cubed minus 2z to the 8th, okay? And I said to you, do you see any like terms in this polynomial, okay? This is a 5-term polynomial. So we have to look at those 5 terms and we have to say to ourselves, okay, do we see any terms that have the same variable and the same degree? And the answer is yes. In fact, there's 2 sets of them. So if we look at these 2 terms here, right, 5z to the 8th and 2z to the 8th, they have the same variable, right, z, and those variables have the same degree, 8. They're both being raised to the 8th power. Those are like terms. And there's actually another set. Do you see it? Another set of like terms? Here they are. Negative 4z cubed plus 6z to the 3rd, okay? They have the same variable, z, and those variables have the same degree 3, right? They're both being cubed. So in that example, we have 2 sets of like terms. Okay, so let's look at our second example now. Here you're going to notice we have 2 quantities being put together. So the quantity 4x cubed plus 2x squared plus 7x plus quantity 2x cubed plus 5x squared plus 6x. And if I said to you, do you see any like terms there? You should immediately say yes, right? We're looking for same variable and same degree. Here's our first set. 4x cubed and 2x cubed, those are like terms. Same variable x, same degree 3. Here's our next set of like terms, 2x squared and 5x squared, right? Same variable x, same degree 2. And we have one more set of like terms actually. 7x and 6x, same variable x and same degree. Those are both being raised to the 1st power. It's like there's that little invisible 1. So in that example, we actually have 3 sets of like terms. So when you're thinking like terms, you're thinking same variable, same degree, okay? Terms that share those. So now let's look at how do we add polynomials and how do we subtract them. Now that we know all the terminology that we need, let's jump into the actual math.